this is a continuation on quadratic sequences, and we're now going to look at as complicated as a quadratic sequence gets. So I want you to think about a quadratic sequence, and you should be used to that form ax squared plus bx plus c. So clearly this is our quadratic, and then you should be quite used to having something added or taken away from it. And this part, if you think about it, is linear. So you've got the quadratic with this linear added or subtracted from it. And again, you should know how to do linear sequences. Before you get onto quadratic, you certainly should have learned how to do linear. So let's look at a linear sequence just to be sure. So there's a linear sequence, and what would we do? We'd go for the first difference because it's linear, and there we will find our constant. And we can see that it's going up in twos, so it's the 2 times table, 2n, but it's not starting from 2. 2 times table would be 2, 4, 6, 8, 10. It's starting at 3, so it looks like we're adding 1 to it. And let's just check. 4, yeah, the difference is 1, difference is 1, difference is 1, difference is 1. So that would be this linear sequence. And so you could easily have something like x squared, or let's use n, seeing as that's what we're working in, n squared plus 2n plus 1, which shouldn't look unusual to you because you're used to that form. Okay, so let's see how we work out these, where we've got a quadratic but also a linear sequence as the difference. I'm going to wipe this, and let's go back to our sequence. So we'll start exactly the way we would always start. So we're going to look for the second difference. So I'll write first difference, second difference. And the first difference, well, we've got 1 to 5, so that's 4. 5 to 13 is a difference of 8. 13 to 25 is a difference of 12. And 25 to 41 is a difference of 16. And now we go to the second difference. Between 4 and 8 is 4. 8 and 12 is 4, 12 and 16 is 4. So that's showing us that this is a quadratic sequence because we've got a constant at the second difference. What do we do now? We halve that to get our coefficient. So we know we're looking at a quadratic. Keep going back to x, sorry. Let's keep it at n so we know what we're doing. 2n squared. Okay, so what we would do at this point is look for how 2n squared differs from our sequence, and we're going to do that. So I'm going to change colour. 2n squared would give us, well, if n is 1, that's just going to be 1, so it's going to be 2. If n is 2, n squared is 4, times 2 is 8. 3 squared is 9, double it up and you get 18. 4 squared is 16, double it up, you get 32. And 5 squared is 25, double it up, you get 50. So we're actually, it's just the square numbers doubled. 1, 4, 9, 16, 25 becomes 2, 8, 18, 32, 50. Now let's see how that differs from our original sequence. And what I might do is just rub out these so we can see it nice and clearly. Let's get rid of that. Okay, and I'm going to move that up and we can see more clearly the difference. Okay, we've lost a bit of the 41 there. So we have got a difference of, instead of 2, we've got 1. So it's 1 less. Instead of 8, we've got 5. So it's 3 less. Instead of 18, we've got 13. So it's 5 less. And we can see a pattern coming here now. Instead of 32, we've got 25. So that's 7 less. And if we look at, instead of 50, we've got 41. So that's 9 less. Okay, so that is the difference. And it's not just an added amount. It's not the same amount added each time, which we've seen in others. So what we are looking at here is a linear sequence. So the difference is a linear sequence. So let's see what the linear sequence is. So from -1 to -3, that's gone down -2. It's gone down -2 again, -2, -2. So now we can be sure it's a linear sequence because the first difference is a constant. And if we're looking at -2n, then we would expect that to start at -2. But instead it's starting at -1. So it's -2n plus 1. You can check here because look, if we've got -3, so if we replace n with 2, then we're going to get -4 plus 1, which is -3. Okay, or the other way, you could just put in, that's -2. And if you look, each time we've got 1 more. So our finishing quadratic is 2n squared minus 2n plus 1. Okay, and that is the nth term for that sequence. And what we could do, if we want to be sure, we could put one in just to make absolute sure it's right. So let's look for the 4th term, which should be 25. So when n equals 4, 4 squared is 16, times 2 is 32. When n is 4, minus 2n is going to be 4 times 2 minus 8. And then we've got plus 1. 32 minus 8 is 24, plus 1 is 25. So we're correct. Okay, so there's quite a lot to it, but I think this is a good way of really familiarising yourself with how a quadratic sequence works. And of course, it's really nothing new that you're looking at as a concept. It's just having to work them out. Let's try one more. Okay, so another quadratic sequence. Now, we don't just know it's a quadratic sequence. I'm saying a quadratic sequence. I know because I've written it, but we can prove it's a quadratic sequence. If we're not told, we know that if the second difference is constant, then it is a quadratic sequence. So let's see. So from 4 to 13, that's gone up by 9. 13 to 26 has gone up by 13. 26 to 43, that's 13. That's 17. And 43 to 64 has gone up by 21. Okay, so that's the first difference. Let's look at the second difference. 9 to 13 is 4. 13 to 17 is 4. 17 to 21 is 4. Good. So we've got a second difference that's constant. So we know it's a quadratic. And then we can halve to find the coefficient, which gives us 2n squared. Okay, so that's the first bit done. We've found our quadratic. Let's change colour. And I'm going to write what 2n squared would be. So you should be getting really good at these by now. If you know your square numbers are 1, 4, 9, 16, 25, then double that is going to be, instead of 1, we get 2. Instead of 4, we get 8. Instead of 9, we get 18. Instead of 16, we get 32. And instead of 25, we get 50. So that's 2n squared. And now we're going to look at how our sequence differs from 2n squared. So let's have a look at that. And again, I can delete out these numbers if they just make it a bit more confusing. Let's get rid of that. And I could move that up a bit. Now, I know you can't do this when you're working them out, but as much as you can keep methodical is good for you. But while I'm teaching you it, I think it's important you can see what's going on. Okay, so what is the difference we've got here? Well, instead of 2, we've got 4. So that's gone up by 2. Instead of 8, we've got 13. So that's gone up by 5. Instead of 18, we've got 26, which is an increase of 8. Instead of 32, we've got 43, which is 8 plus 3, 11. And instead of 50, we've got 64. So it's 2n squared plus this sequence here. And that looks, because we haven't got a constant, it looks like that is a linear sequence. So we're going to do exactly what we'd do with a linear sequence. We are going to look at the first difference. So between 2 and 5, 3. 5 and 8, 3. 8 and 11, 11, 14. Good. So it's 3. And so that tells us it's 3n. 3n is the 3 times table, of course, so it should start at 3. We should have 3, 6, 9, 12, 15. Instead, we've got 2, so it's 1 less. Okay, and you can just check. It's 1 less there, it's 1 less there, it's 1 less there, it's 1 less there. Good. So what we end up with is, and I'm going to go to a different colour again, it's 2n squared, and then it's got 3n minus 1 added to it. So that is our quadratic. That is the nth term for this sequence. And again, we can check it out. So let's do that. Let's look for the 5th term. Okay, that's the 1, 2, 3, 4, 5th term. So we're going to say n equals 5. So n is 5, n squared is 25, doubled up is 50. N is 5, 3 5s are 15. And then we subtract 1. 50 plus 15 is 65, minus 1 is 64. So that's good. Okay, and that is quadratic sequences.